overview of the CMC test set. We'll review the front, the back, the various inputs and outputs. Next, we will learn what we need to get started using the Test Universe software in conjunction with the hardware asset. Following that, we will learn to set up the Test Universe via the start page. Then we'll discuss the Omicron philosophy of testing, followed up by a view of the actual QuickCMC test module itself. And lastly, we'll close with a short question and answer session. So a quick review of the front of the CMC. Here we have a picture of a CMC 356 test set. You'll see that it has various voltage and current outputs, a DC supply, various binary outputs and inputs, and if you do have the LT1 option, it also allows for DC measurements for current and voltage. Looking at the back or the rear of the test set, we'll see it has the standard power supply outlet. Below that, there will be a fuse, various fans for the cooling of the test set, the external interface where you can connect additional sensors such as like an arc flash initiator or a optical pickup for like meter testing. Below those, you'll see some low-level outputs, which you can use to connect various amplifiers or what else can you connect? You can break out the low-level outputs or the transistor outputs via those. To the right of that, you'll see the test set association button, a USB port, and 2 Ethernet ports. Please note that some of you may have a parallel port connection on the rear of your CMC. That is an older type of connection, but it is still available in many of the test assets which we have out there today. So in order to get started using your test set, you will first have to install the Test Universe software. This will usually have come with your test asset in the form of a CD. However, you can also download the latest version of the Test Universe software directly from our website. We have an area on our website called the Customer Care area, where you can download the current as well as previous versions of all the software which we have available, including the protection testing library for various templates. Next, what you'll do is you'll connect the CMC to the wall outlet and the computer, either via USB, parallel port, or Ethernet. Continuing, we will power on the CMC using the red I/O button on the front panel, and then double-click the Test Universe start page, which should be installed default to your desktop. To control the test set, Omicron provides the Test Universe software, which offers various modules to test all types of secondary devices. The Omicron Test Universe functionalities include convenient manual testing, which we'll go over today, testing with software modules which are optimized for specific test object functions, such as overcurrent or distance protection or differential protection. We offer generic testing, which allows for the creation of special tests for special requirements. And we offer the ability to combine all of these elements in an overall test plan via the control center. One unique thing that Omicron does also provide is the protection test library, which has predefined test templates, which are provided free of charge by Omicron. In this webinar, we are going to present the setup options used to enter the basic settings in order to prepare the test equipment for use. And we will also go over the QuickCMC test module which is used for convenient manual testing. So in order to begin, we're going to first need to establish communication between your test asset and the software itself. So in order to do so, you first need to either connect directly via the parallel port of the CMC, the Ethernet interface, or the USB interface. So with the test set association component, you associate and configure your CMC test set, and do so after you've connected with especially with the Ethernet and the USB interfaces. You'll need to open up the test set association and configuration, which can be found in the upper right-hand corner of your test universe start page under Setup. It's highlighted here in the upper right of the slide as well. So once you click that, it will open up a new window, one that you'll see at the bottom of the screen here. And you will most likely see the status next to your CMC, which says test set is not associated to this computer and therefore cannot be used. So what you'll need to do is you'll need to highlight your test set using a left click of the mouse and then select the Associate button from the upper left-hand corner. The software will then prompt you to press the Association button on the rear of the CMC, which is that little black button which we had pointed out earlier. And upon doing so, you can hit the OK button to confirm that you have actually pressed it. The status should instantly change to test set is ready to use, and you should be good to go there. So using this association via the Ethernet interface, we can put as many CMCs test sets as we wish on a network, and we can control them from a distance, so even geographically remotely. So it's one of the advantages of using that. Next, we'll take a look at the system settings under the setup. So system settings provides a means for system-wide default settings. The parameters entered into the user information tab are used system-wide. So here we can enter the username, the manager, so for example, the substation manager, whoever's in charge, and the company name. So what this will do is whenever you generate a report for your test, it will automatically populate this information in for you. So there's no need for repetitive entering. The open file and file save command can be found in the directories tab. So here it provides a place where we can save all of our test documents in different templates, so default folders. So this can be very useful for just file handling and knowing where all of your tests are. In the phase names tab, it is possible to define the name of 3 phases to apply throughout the test universe software. I believe defaulted, it'll be that L1, L2, L3, and E. I know some people prefer to use A, B, C, and neutral. If you don't like any of the options that we provide, you can also select the custom option there and then type in whatever names that you would like for your 3 phases in neutral. The next tab, which I think is the most important of the system settings tabs, is the default values. So in this tab, a user can enter default values for voltage, current, and frequency. You can also define default values for the limit of the voltage and the current. You can configure the configuration of the binary inputs, as well as the contents of the reports which you will generate from your tests. So one thing to note is the limits for your Vmax and Imax must be set high enough in order to configure the test that you're interested in performing. So I believe it's defaulted to something like 200 volts. So if you are looking to output higher voltage, and you might receive an error saying, please enter a voltage value between I don't know, it's negative 120 and positive 120, but you say, hey, I need to output 250 volts, then this is where you would come to check your Vmax value and make sure that it is acceptable for whatever test that you're trying to perform. The Omicron News is an information service, so it provides you with relevant messages such as the availability of updates for any Omicron products that you have installed, as well as some general Omicron product information and news. Here we can configure the settings to be displayed. So if you find that you're not interested in receiving these updates, then just select never, and you should be all set. The Export Data tab, here we can define the default settings for data export. So if we want it to be an XML file, CSV, and the different CSV delimiters and text qualifiers. The last tab in the system settings is the sound settings tab. Here we can assign various sounds for whenever an overload is detected, as well as when a pause module from the control center is initiated. The Omicron Test Universe software is protected from unauthorized installation through the use of license files. The license file codes, which you can see in the bottom right-hand corner there, they specify both the individual test modules and the hardware serial numbers. So the master license file, which you'll see in the middle there called omicron.lic, will be automatically installed to your computer when you install the Test Universe software from the CD provided to you when you received your test set. If you do not have this, you will not be able to use your test set. So this is something that is very important to keep and to store safely. So if at any point you decide to purchase any additional Omicron test sets, you'll need to add their license codes to this master license file. And to do so, we use the license manager. And the license manager combines the functionality of a license browser, a merge tool, and a license file editor. It searches for various Omicron licenses files stored on the computer's hard disk and displays their contents. It can merge various license files together into that master license, so you just need one file instead of having various licensing files. And furthermore, it allows for the addition of individual license keys, which can be entered manually. The last option under setup is the language selection. So the language that you select when you install Test Universe will be the default language when you open up the start page. However, at any point, if you'd like to change the language, you can select it from this drop-down menu here. Please note that if in the drop-down menu you see various squares, that means that you do not have that, the language package installed in your Windows on your computer. So that's something that you would have to download via Windows to enable in order to enable that language selection. So that covers the setup of the test set. Now we're going to jump into the testing philosophy of Omicron. So regardless of whether we create a control test document for a more complex functional test, or we use a standalone test module, the order in which we create a test will always be the same. First, what are we going to do? We are going to define the test object parameters. So for each test module that is capable of running either again standalone or embedded in that control center document, it acquires specific data of a physical test object, which is the device under test, which is most commonly a protection relay, from a data container, which is called the test object. So the test object has a user interface, which is called the test object parameters window, and it serves as a parameter management tool. So upon completing that, we will then decide with what are we going to test. So that will be the test hardware. And to do that, we must define the hardware configuration parameters. So depending on the type of CMC test set and or if we're using any type of CMA or CMS amplifier, the test universe will allow for many different types of tests. In the broadest sense, the test hardware can be seen as an adaptation between the test software and the test object. For example, an output signal of a test software is physically applied to the CMC test set output and then connected with corresponding test object terminal by the wiring. Lastly, we'll discuss how we're going to test. And to do so, we will use the individual test modules or combined test modules which are provided within the test universe software. So to do that, we will need to set the test module parameters. And the various function-oriented test modules of the test universe are the components that will actually control, execute, and then evaluate your individual tests. So if we take a look here, and since we all know Ohm's law, the basic working order with test universe can easily be kept in mind. So first we want to define the test object, which is the O of Ohm's law, H for hardware configuration, and then M for the test module. And this is what we call Ohm's law of Omicron, or Omicron's Ohm's law, which is a very convenient way to remember how to set up and start with your test. So now we're going to jump in and take a look at the QuickCMC test module. So bear with me while I open this up on my computer, and I will bring it over to the screen shortly. So here is the test universe start page. I'll click QuickCMC from the upper left-hand corner under test modules. And here we go. So the QuickCMC test module has been designed for straightforward, quick, and easy testing. It allows for you to access all the current and voltage generators of the CMC test device directly, and it enables the states of the binary inputs, or binary and analog inputs, to be read out. However, in its basic function, the module does not contain any information about the protection functions that you're going to test. So it's not going to know that you're testing, instantaneous overcurrent element. You will have to evaluate the response of the test set and the response of the tested object, which is most likely your protection relay. You have to evaluate those responses manually. So it's possible, in principle, to test virtually every protection function. However, you'll have to understand more of the individual functions on the relay itself. But the QuickCMC is still very useful, and it's best suited for straightforward wiring and commissioning tests. It can also be used as a diagnostic tool for various troubleshooting. So in accordance with the Omicron Ohm's law, we're going to start by configuring the test object. To configure the test object, we will click the test object button. So it's here in the upper left-hand corner. And if you mouse over it, you'll see that there's a shortcut that you can use to also get to it, which is Control-T. So if we just hit Control-T, it will open up this window. So in the test object, we have to define various data relating to the protection device to be tested. These parameters are used to set specific current, voltage, or frequency values automatically. For example, or to add an entry to the test report indicating which protection relay has been tested. The RIO that we see here, that's green, stands for Relay Interface by Omicron, and it includes functions for the specific purpose, which I mentioned before. So we need to first set up the device. To do so, you can double-click on device or single-click and select Edit. So in this device settings, it will pre-populate any of the default values which you had previously set up in that system settings window. If you're interested in entering any additional values, you can enter in, various information to uniquely identify the protection relay here on the left-hand side under the device. We can specify, additional substation information, bay information, the nominal values, residual voltage and current factors, the limits, and the debounce and deglitch filters, as well as the overload detection for sensitivity. So with the debounce and deglitch filters, there's a lot of questions regarding this. You can configure the debounce filter for input signals with bounce characteristics. So if a filter is configured, the first change in the input signal causes the signal level to be held fast for the duration of the debounce time. And the debounce function is connected to the deglitch function in series. So now I'll talk a little bit about the deglitch of the input signals. So in order to suppress short false pulses, a deglitch algorithm can be configured. The deglitch process results in an additional dead time and introduces a signal delay. So in order to detect as a valid signal level, the level of an input signal must have a constant value at least during the deglitch time. If you'd like to read more about this, you can use the help function. And the help function is extremely useful in my opinion. So here are some illustrations for outlining the deglitch and the debounce. So if you're interested in that, just take a look here, and I think it covers it quite well. So after we can enter in whatever information here, you select OK, and it'll get saved into that data container, and it'll be referenced later. You'll notice below is also a distance RIO here. This is where you can set up distance parameters. However, we're not going to go into this today because this is a separate webinar, because we offer various distance protection modules as well. But I'll go over the basics. Basically, you can enter in some your impedance characteristics for distance protection. So you can enter mho, arcs, and Cartesian, and then they will show up basically on your impedance view as a mho circle or a Cartesian impedance, and then you can test various distance elements using that. So after we have set up our test object, we have the ability to save this test object if we want to use it in the future. Say you're testing, 50 IAC overcurrent relays that all have, the same characteristics. One thing you do is you set up the device once with the information, and then export this test object for use later. And same, you can also import in various test objects just so you don't have to enter that data in multiple times, which can be a time saver at times. So upon entering in all the test object information, we're going to move on to the H of the Omicron Ohm's law and configure the hardware configuration. And you'll see here in the upper left, it is right next to the test object. And if you mouse over it again, you can see the shortcut is Control H. So we hit Control H, it opens up the hardware configuration tab. So in the hardware configuration, we can define how the connected test device is to be used. On the first tab of the hardware configuration, a dialog box contains fields in which you can specify which CMC test device, if applicable, which additional amplifiers can be used. So I'm not actually connected to any test sets right now. However, if I had to any test sets connected, you would see them listed here. And instead of the question marks, you would see the serial number of the test set. Additionally, the same thing with any type of amplifier which you would be using. Here, if we select, let's just use an example, if we say we're using a CMC 356, you can select details to enter more detailed information. So this will open up the output configuration details, and in this window we can specify which voltage and which current generators are to be used with which interconnection option. So for example, if we need to achieve high voltage when we want to output 600 volts, you'll see that the connection diagram here will be different than if you are just trying to use 4 channels of 300 volt output. Additionally, we can disable various generators if we don't plan on using them. If we want to connect any CTs or VTs, we can define the data for the transformers connected to the CMC test device and protection devices here. So let's open this up. So these transformers provide the means for generating higher output voltages and currents. The maximum power that can be achieved by the CMC test device will still remain the same. So for example, if you're outputting, if you're using like a 4 by 900 volts, can be generated with a transformer for, let's say, wind power stations, for example. So upon completing the configuration of that, we'll hit OK. Come back to our hardware configuration window, and we'll take a look at the analog outputs tab. So further settings affecting the analog generators will be made here. On the leftmost column, we'll see the test module output signal. So here we can select which function is assigned to the analog generator for the test module. And the first 3 voltages here are assigned to each phase. You'll see 1, 2, 3, and it's defaulted V1, VL1, VL2, VL3 to earth. So each of these currents here is matched 1-to-1 to the current phase as well. And you will note that in order to enable additional currents or voltages, we'll just have to go to the drop-down menu and select various signal names in order to enable them. And now they'll be enabled. The connection terminal here is where you can specify which connection terminal in the cabinet or on the protected device to wire corresponding to your test set. One thing to note is that changing the assignment of the test module output signals can also change the physical properties of the analog output signals. For example, counter clockwise or clockwise phase sequence. If we look at the next tab over, which is the binary analog inputs tab. So on this tab, we can define which binary inputs signals are connected. So we have to specify whether the signals are potential free or not. In the latter case, you have to specify both the nominal range and the threshold. So for example, let's select binary 1 and say that is going to be a potential sensing contact. So we specify a nominal range and a threshold. So any voltage above this threshold voltage will be evaluated as a logical 1, and any voltage below this threshold voltage will be evaluated as a logical 0. Next, we can take a look at the binary outputs tab. So if we want to use any binary outputs you have to configure them here. And you can define various signals to be used, for example, like circuit breaker position. You can configure your 52A, 52B using these. Lastly, we would take a look at the DC analog inputs tab. So here is where you can define the ranges for your input. So this is mostly used for transducer testing. You'll output some power through the transistor, and usually you'll get a DC current back in the 1 milliamp to 20 milliamp range. You can select whatever range you'd like, read it in just to verify calibration of transducers. So after we set everything up, we hit apply, and the same thing as with the test object, we can import and export our saved settings in case we have the similar hardware configuration for various different tests. So we can export it and then import it back. So now we can take a look at the test module itself. So if we take a look here in the upper left of the test view, we see that we have the analog outputs. So here we can enter the actual current and voltage values to be output by the CMC test set. Various input options are available under the set mode. So we'll see here that these include symmetrical components, line-to-line values, and other specific types. This option is known as the fault calculator, and it makes generating the necessary signals much easier. So the next area we can look to the right of that is the binary outputs. So here we can specify which state of the binary output should be adopted here. A check mark in it, a check box next to a binary output indicates that the relay contact is closed at the start of testing. To the right of that, the signal outputs are shown here in a vector diagram in the test view, right here. So for example, if we were to enter some values in for voltage, you'll see the corresponding signals here. Note that you can also drag these around in case you want to change them like this. What else is there? Take a look at, so below that you'll see the analog inputs. So this is going to constantly monitor the status of those DC inputs on your CMC if you have the ELT1 option. So you get a real-time view of that here. If we take a look at below that, we'll see the binary analog input area. So here you can see the current state of the binary inputs. A red dot will indicate whether a signal is pending at the relevant binary input. If a change of state occurs during the test, the corresponding time is entered to the right, currently where it says not applicable. This means that the pickup and trip times can be measured. So if a check mark here is checked, it means that if on the trigger, it will switch off the test set, or it'll cut the outputs of the test set. So if this is also checked here on the switch off on trigger, and note that you can enter a delay here if you'd like. Below the trigger area, you will see the step and ramp option. So the settings in this section can be used to ramp the signal output. So you can change them incrementally in steps. So this means that it's possible, for example, to increase the current in small steps until a pickup signal or a trip is triggered. And again, you'll see the corresponding time in the binary inputs monitor area. Let's take a look up top now in the home. We'll see that we can set a pre-fault state prior to initiating the start of our test. And we'll note that the pre-fault values are the default or the nominal voltage values set in the test object, and that the current will always be 0. You can start your test by using the start button, and correspondingly, if you want to stop your test before a trip signal is detected, you can use the stop button. The hold values, you can click the hold values button to freeze the values of the signal currently being output. So as long as this button is activated, you can change the values within the fault calculator without the changes being applied to the output. But once the changes have been made, you can then press the hold values button again, and then all the changes will instantly be applied to your previous settings. Another button to the right of that is Add to Report. So once a test has been completed successfully, the results can be evaluated manually by pressing the Add to Report button. So what I will do is I will simulate a test. So I'll just set these to, let's say, 0 for now. And I'll say I'm outputting some current to try to test, some type of current element, and I hit start. So boom, outputs, we see that we tripped. We see that we tripped on the downward edge at 1.266 seconds. And we say, hey, that is a great result, and that is what I want. What we can do is we can select Add to Report, and then you can give this little test a title, a comment, and then you can manually assess this test as either passed or failed. So we'll say passed. Now if we take a look at the report view, you'll see that it adds this test that we just performed, provides the information of the trip, gives you the time, and then it tells you that, yes, this is a passed test. You can, again, also look at the impedance view. Again, if you were going to create a distance element, you would see it here. One of the views, if we go back to the report view, here we can configure, the various views that we want to see. So if we want to see more information, we can open up this report settings tool and then configure what additional information we would like to be included in our report. For example, the information that we entered in the test object, which will have the information about, what type of relay we're testing, where we are, the serial number of the relay. So depending on what information you would like to include in your report, this is where you would select it and enable it. There are defaults that we create, a short form and a long form, just to help you out a bit in case you don't want to actually configure your own. You'll see that this is the long form. It'll have some additional information, but I don't believe it's all of the information. If we go back to that View tab, we can see that we have different display options. So if you'd like to see your test results in cycles, you can do that. You'll see that it's 89.08 cycles is 1.485 seconds. You can see your values in primary and secondary values based on the information that you entered in the test object, and you can toggle between absolute and relative values as well. So, like per unit. So that pretty much covers the QuickCMC module. Does anyone have any questions? Feel free to type them in, or if your microphone is not very staticky, feel free to unmute yourself and ask any questions. So someone asked to see the templates. So I don't actually have I don't believe I have any templates installed on my computer currently. I just got a new computer. Let me take a quick look and see. Yeah, I can show you where to download them. Let me open up our website quickly. Here it is. So what you'll need to do is to log into the customer care area of the website. And you'll go to software downloads, protection testing library. Just take a look at the library and you'll see, you can filter by various relay manufacturers or, different applications of the relay. Let me just download something that is, let's download some of the CO. So you'll notice that, there's a lot of, the CO11, CO2, CO9, and these will, even though if you click on different ones, it'll bring you to the same download, basically, because it's all the same type of relay. It follows the same functionality. So it's installing the PTL right now, or the PTT on my other window. So I'm just going to next through this stuff. Finished. Okay. So let me bring this up. So I'll open the PTL, ABB, CO, and I'll drag my window over shortly. So what it'll prompt me to do is enter in some additional relay information. So with the COs, you can just pull this directly from the face of the relay itself. So you can select, whether it's a 2, CO2 through CO11, various internal schematics, the tap settings, all this information. I'm just going to leave it as default for now. And then this is optional information just for your own references. This is a good place to pay attention to the current and time tolerances. I know with some of these old electrical mechanical relays, the time and current tolerances are a little more lenient than with the digital ones. So after we enter all that information, we will get a pop-up. It'll show us, hey, this is how you connect into your relay from your test set. Hit continue. And then you'll get a nice little test plan like this. And it'll have various tests that you can run, and you just run through them, and you'll basically will have tested the full functionality of your relay. So I have another question. I have a few questions, so I will go through them in order. Can you please explain what are the checkboxes in the hardware config for binary inputs? Absolutely. So let me open that up again. QuickCMC. So in the test object, in the hardware config. So I believe you're referring to these checkboxes. So these you can assign various signals to the various outputs or the binary inputs of the CMC. So you'll notice on the front panel, if you have a 356, you'll have 10 binary analog inputs. And you can assign them to various, let's say I want my start to be on 1. I can assign the signal there. And then I can assign the signal for trip on 2. But the easiest way, I think, is just to leave it like that, and then you can assign the signal in the test module input signal. I think that's the easiest way to do it. However, if you would like to do it by assigning using the check marks, then you can do that. Yep. So the next question is, I think there's a filter in the Omicron website used with distance relays for doing PTLs and X-RIOs. How can I use this filter? The filter. Let me try to find what you're referring to. That's not it. Maybe an X-RIO converter. For distance relays. I'm not too sure what you're saying with this, but I think one thing that we do is if you would like to import in your relay settings and we do not have the template already defined for it, you can download a file. I believe it's in the form of a Excel file, and you can manually enter in all of your file settings, and then you can import in, like an Excel file of relay settings into your test object parameters, and then that will help you do it. Yeah, anyone can do this. It requires a little bit of like typing in various relay settings, and it can be buggy if you do not include all of your relay settings. So yeah, it's definitely possible. I'm not going to go over that during this.
Yes. Sorry, yeah.
Yes.
This,
What? Yes.
this Rio filter, this last one, Rio filter. How can I use this?
Yeah. So this is not something that is covered during this webinar. We can take this discussion offline if you'd like, and then I can try to explain to you how to do it later. Is that okay?
Okay, thank you.
Okay. Does anyone have any additional questions regarding the QuickCMC module or setting up the Test Universe software? Okay, if not, I will end the session, and Tazeen, I will have a private chat with you with regards to how to use that relay filter. Let me see where we were at. If you guys have any feedback or questions, any comments regarding our training, please feel free to drop an email to training@omicron.at. Any feedback is really appreciated. It helps us make these webinars better for you guys, and it helps us in terms of things that we need to work on. But thank you so much for attending, and I hope to see you guys again in the future for some of our other webinars. So the webinar was recorded, and you will be receiving a link with the recording from our training mailbox at some point in the near future. But I do not have the link to send to you. It'll be someone from our training department sending you a link with it too.